Alright, this video is about vector valued functions, and this is part 1 of 2. So this is day 1, vector valued functions. Part 2 is day 2. So first of all, we're going to write a definition of a vector valued function, which is a function of the form r of t equals f of t I plus g of t j, or r of t equals f of t I plus g of t j plus h of t k. And these are vector valued functions where the component functions f, g, and h are real valued functions of the parameter t. Vector valued functions are sometimes denoted as r of t equals f of t comma g of t, or r of t equals f of t comma g of t comma h of t. Alright, so number 1, we want to sketch the plane curve represented by the vector valued functions r of t equals 2 cosine of ti minus 3 sine of tj. So x is 2 cosine of t, y is negative 3 sine of t. Or cosine of t is x over 2, and sine of t is y over negative 3. So let's just say we have this, which is one of our trig identities. If we replace the cosine of t with x over 2 squared, and the sine squared with y over negative 3 squared, we get x squared over 4 plus y squared over 9 equals 1, which is an ellipse that goes out 2 and up 3. And we look like this. Alright, number 2. We're sketching a space curve represented by the vector valued function negative 4 cosine of ti plus 4 sine of tj plus tk. And we're going from 0 to pi over, or 4 pi. So x is 4 cosine of t, oh, that's an equal sign. Y is 4 sine of t. So cosine of t is x over 4, sine of t is y over 4, and then z is just t, so that one's not that bad. Again, we're going to use that trig identity of ours. So x squared over 16 plus y squared over 16 equals 1. So we have x squared plus y squared equals 16. So those are circles. Problem is we're three-dimensional because we also have z that's equal to t. So we're kind of circling upwards in a spiral fashion. So if we have our x, y, z axes, we start with a radius of 4. And we kind of just rotate upwards in circles. So this is called a helix. We're kind of just rotating upwards in a circle to make a cylinder type shape. Alright, so represent the parabola by a vector valued function. So let's say we let x be equal to t. So then y is equal to t squared plus 1. So then our r of t is ti plus t squared plus 1j. That's it. Quick and simple. Alright, and number 4. We want to sketch the space curve C represented by the intersection of a semi-ellipsoid and the parabolic cylinder, then find the vector-valued function to represent the graph. Alright, so I'm going to let x be equal to t and y be equal to t squared. So then z squared over 4 would be equal to 1 minus x squared over 12 minus y squared over 24. If I plug in my t values, so x was just t, so that's t squared. Y squared is t squared, so I end up with t to the 4th. Find common denominators over on that side. We get 24 minus 2t squared minus t to the 4th over 24. The numerator we can factor. So we get 6 plus t squared minus 4 minus t squared over 24. Multiply both sides by 4. And then square root both sides. And all we gotta do now, if I were on the page you could also see what I'm doing. So now we've got z, we got x and y, so all we gotta do is plug these in. And we've got our vector valued formula. And we're not going to sketch these because they're atrocious to sketch, so we just found the vector valued formula to represent the graph. Since they are intersecting the parabolic cylinder, if we wanted to write that as a function as well, we would just end up with the first part of this, so we don't have to address that separately. But that is all for today.